Hello, I'm Kyle. I'm the technical content developer at Maple Systems. Welcome to the Maple Systems video training series. In this video, I'll be covering the ladder diagram logic to control the speed of a DC motor by changing the duty cycle using a PLC IO-SD0032PPWM Modular PLC and an IO-SD0032PPWM Module in MapleLogic. Okay, here is a wiring example of connecting a Maple PLC to a PWM module, to a terminal block, then to a DC motor drive module, to a DC motor. Now first, a power supply is going to be supplying 24 volts to the Maple PLC. The PWM module is connected to a terminal block through a terminal block connector cable, and then the terminal block has a PWM output going to the DC motor drive module, and a DC motor drive module going to a DC motor. A DC motor drive module must be used to support the power from the PWM module. If you do not use a DC motor drive module, you risk damaging the PWM output channels. Now that same power supply that's supplying 24 volts to the Maple PLC is also supplying 24 volts to the terminal block. It's going into A10 or B10 and having them both jumped, so the entire terminal block has 24 volts of power. And then 0 volts from the power supply is going into A20 and B20, which is the ground on the terminal block. Now, as you can see on the terminal block, there are 3 frequency groups, groups A, B, and C, and each have 4 channels, so that's 12 PWM channels in total, which is how many are on the PWM module. In this example, I am going to be using B4, which is channel 4, A2 is channel 1, B2 is channel 2, A4 is channel 3, and I'll be using B4, so the PWM output signal will go into the drive module, and then from A20, that will go into the 0 volts on the DC motor drive module. And then I have a separate power supply providing 24 volts to the drive module, as well as the 0 volts into the ground on DC motor drive module. That is to power the DC motor drive module, and this is to send the PWM output into the drive module. In this wiring example, you could use one power supply depending on your setup and if you can provide the right amount of current to all of the devices. And then finally, the PWM output is going into the DC motor from the DC motor drive module. Now let's go back into MapleLogic, and in the previous video, What is pulse width modulation, I went over the PWM configuration window and how you can use that to control the speed of a motor or dimming of an LED light. I also mentioned that you would most likely use the PWM configuration GUI if you are going to be setting some values that will be constant and not utilize any kind of automation. Now, to use some kind of automation to control the speed of your motor, we would want to have some kind of ladder diagram logic, so that's what I'll be doing in this video. So here is my ladder diagram, and I also have my buffer memory open here because I'm going to be using some of the buffer memory for the PWM module. On rung 2, I am enabling the PWM channel. So M00 is the PWM enable bit. In this application instruction, I have 2 to the PWM module. H0001 is slot 1, which is the PWM module. 0 is the PWM output enable. And then H0008 is channel 4 for the PWM module. So why is channel 4 for the PWM H0008? Well, this is the hexadecimal for that channel. So to understand H0008, you have to understand how to figure out the binary of the hexadecimal. An easy way to do that is to use a calculator on your PC, and you would just go to the programmer calculator, and under binary, you're going to use this chart to figure out what the hexadecimal is to put into your application instruction here. And to figure out what the binary is of the hexadecimal, which is H0008 for channel 4, you can see here that there are 12 channels. So that's 12 channels of the PWM module. And then there's a total of 16 bits, which is one word. So because there are no 12, 13, 14, 15 bits for the PWM module, it's going to end at 11. So it's going to be 0 through 11, which is channels 1 through 12. So for channel 4, that's going to be bit 3. So to figure out what the hexadecimal is, you go to binary, and then you'll enter 1 followed by 3 zeros for channel 3, 2, 1. So be 1, 0, 0, 0. And it gives you an 8. Now you know what channel 4 is for the PWM module. You'll go up to your application instruction and type H0008 for channel 4. Now I'll show you a few more examples of how you would figure out the hexadecimal for each channel. So what if you wanted to turn on channel 4 and 1? Well, that would be similar, except you would do 1, 0, 0, 1. So your hexadecimal for your application instruction would be H0009 to turn on channel 4 and channel 1. Well, one more example, what if you had 3 channels you wanted to turn on for your PWM module? Well, let's clear this out. Let's say you wanted channel 8, 4, and 1. So for channel 8, you would do 1, and then 0, 0, 0, channel 4, 1, 0, 0, and then 1. And you get 89. So the hexadecimal you would type in to your application instruction would be H0089. And if you wanted to refer to these charts, if you're trying to figure out the hexadecimal that you are trying to plug in, these charts can also be seen on the How to Control the Speed of a Motor Using PWM tutorial page on the Maple Systems website. Let's now look at the rest of the logic here. So the motor is being enabled and then increased to 25% duty cycle. So from 0 to 25% duty cycle, and then to 90% duty cycle, then down to 50% duty cycle, and then down to 20% duty cycle, eventually turning off here. Let's start back up at M01. So M01 is an internal bit that's going to trigger the entire logic sequence all the way down to the last rung here. So what I mean by that is that initially it's going to trigger an on timer, a TON timer, that's going to start a 10-second timer, which will eventually trigger this at 10 seconds. But while it initiates this TON, it's going to initiate this logic here, which is moving 5 seconds to D10 for the duty cycle ramp time for channel 4, which is 33. And I'm going to be using these buffer memories all the way down to the very end. And then 13 is channel 4 duty cycle, and then 1 is the frequency for channels 1, 2, 3, and 4, and we're using channel 4, of course, so we're going to be using 1 buffer memory. It's also going to be moving 25% duty cycle into D20, which is for channel 4 duty cycle, and then 500 hertz into D30, which is channel 4 frequency. So the motor will go from 0 to 25% duty cycle in 5 seconds, and then at 10 seconds, it's going to turn on motor timer 1, which will reset M01, so this will turn off, and then set M02 for our next piece of logic. So here's M02, and again, it's going to start a 10-second timer, move 5 seconds to duty cycle ramp time, 90% duty cycle into duty cycle channel 4, 500 hertz into channel 4 frequency. So it's going to do 25 to 90% duty cycle in 5 seconds, and then at 10 seconds, it's going to turn on motor timer 2 bit here, reset M02, which will turn this off, and then set the next set of sequence, M03. So then M03 will do the same thing, except it's going to be 90 to 50% duty cycle in 5 seconds, and then repeat one more time. This one's going to go from 50% duty cycle to 20% duty cycle in 5 seconds, and then after a 10-second timer, it will turn on T3 and then reset M04, and then the motor will turn off. That is all the logic that I have here. So the only thing to do now is to go online and see this in action. So I'm going to have a live camera feed of the motor, and so you will see the motor ramp up to 25% duty cycle, then 90, back down to 50, back down to 20, and then off. So go to online, link plus download plus monitor. Okay, now I am online, and you can see the DC motor here in the live camera feed. So the first thing I'll do is enable channel 4 of the PWM module, and then I'll enable motor bit 1, which will initiate the entire process here. And I'll be counting from 1 to 5, which will be the amount of time it will take the motor to go from one duty cycle to the next. So shift and enter, turn on channel 4, down to M01, shift and enter. 1, 2, 3, 4, 5, 10-second timer. 1, 2, 3, 4, 5, 90% duty cycle, 10-second timer. 1, 2, 3, 4, 5, 50% duty cycle, 10-second timer. 1, 2, 3, 4, 5, 20% duty cycle, 10-second timer. And the motor is off. So this is all I'll be covering today. To get more information, please visit the How to Control the Speed of a Motor Using Pulse Width Modulation tutorial page on the Maple Systems website. I hope you enjoyed this video, and thank you for watching.